Deep beneath the ocean's surface lies a mysterious and otherworldly phenomenon: brine pools, also known as underwater lakes. These bizarre features resemble miniature seas within the sea, complete with distinct shorelines, waves, and even rivers. But don't be fooled by their beauty. Brine pools are some of the most extreme and hostile environments on Earth, deadly to most marine life, and yet teeming with some of the ocean's most unique organisms. So how can lakes exist beneath the ocean? And why are they so dangerous? Brine pools are highly saline bodies of water that form on the seafloor. They are essentially lakes of ultra-salty water that don't mix with the surrounding ocean due to differences in density and temperature. These pools are typically 3 to 8 times saltier than normal seawater, making them so dense that they remain separate from the ocean above them, forming a distinct visible barrier often called a halocline. To the eye, they look like shimmering, wavy surfaces, complete with ripples, shores, and depths. The idea of a lake sitting at the bottom of the sea might sound impossible, but it's entirely real, and incredibly intriguing. Brine pools usually form in regions rich in salt deposits, especially areas with evaporate layers left behind by ancient seas. Over time, these salt layers can dissolve due to subsurface processes, creating pockets of highly concentrated saline water. This ultra-salty brine then seeps through the seabed, collecting in depressions and forming brine lakes. Some pools also form near cold seeps, where methane and hydrogen sulfide bubble up from below the seafloor, adding to their chemical complexity. Notable locations of brine pools include the Gulf of Mexico, the Red Sea, and even the Mediterranean Sea, where ancient salt beds and tectonic activity create the perfect conditions. One of the most striking features of brine pools is how deadly they are to most marine organisms. The extreme salinity prevents oxygen from dissolving into the brine, creating an anoxic, oxygen-free environment. Most fish, invertebrates, and even microbes that stray into the brine will suffocate and die, their bodies sometimes preserved along the shorelines like eerie underwater fossils. Moreover, the brine is often loaded with toxic gases like hydrogen sulfide and methane. These gases can be harmful or lethal to most life forms, making brine pools some of the most inhospitable places in the ocean, yet also some of the most scientifically valuable. Despite their toxicity, brine pools are not lifeless. In fact, they host some of the most extremophils known to science. Unique bacteria, archaea, and even some tube worms and mussels have adapted to thrive on the edges of these pools. Many of these organisms use chemosynthesis rather than photosynthesis, relying on chemical energy from methane and hydrogen sulfide instead of sunlight. These strange ecosystems resemble what scientists imagine life might look like on icy moons like Europa or Enceladus, making brine pools an important analog for astrobiology. Studying these organisms helps researchers understand how life might exist beyond Earth. Brine pools are a powerful reminder that Earth's oceans are still full of secrets. These underwater lakes, deadly to most yet thriving with the rarest forms of life, challenge our understanding of biology, chemistry, and the limits of life on our planet. From their alien-like appearance to their potential to unlock the secrets of extraterrestrial life, brine pools are among the most fascinating and dangerous features of the deep sea. In the shadowy depths where sunlight never reaches, brine pools stand as eerie reminders of nature's power to create both beauty and peril, alien worlds on our own planet that may hold the keys to life beyond it.